Karen, what are you doing?
Oh, hey, I'm working on problem number 2 from the Mechanics of Materials midterm.
Oh.
It's about torsion in parallel.
Okay, I remember that.
You want to help?
Yeah, sure.
Great. Okay, so we have a 60-inch long rod.
Right.
Within a 60-inch long aluminum pipe.
All right.
And a 300 pound per inch torque is applied to the free end.
Sure.
We're looking for the shear stress in each of the materials and the angle of twist, which should be the same for both.
All right.
Since we're working in parallel.
We're looking for the angle at the cross section, right?
Oh, that's right.
All right.
Okay, so we know the angle of twist for the pipe is equal to the angle of twist for the rod, and the amount of the torque that the pipe takes should be added to the rod to equal 300.
300.
Okay, but before we get started, we'll have to find the J and the G.
The J and the G. Okay.
All right.
So let's go for the rod.
Let's start with the rod.
All right.
So pi over 2. And
the radius here is 0.5.
0.5
to the fourth. So that is equal to 0.1 inches to the fourth.
1 inch to the fourth.
Right.
The G, or the shear modulus, is
7,000 divided by 2 times 1 plus 0.15.
1, 5. Okay.
Yeah. And that is equal to 3,043.
43. Now the J of the pipe is a little more complicated. We have to subtract the inner radius from the outer radius.
Right.
So pi over 2 again.
The outer radius will be 1.5.
1.5 to the fourth.
And the inner is 0.5.
0.5.
So that is equal to 7.8.
7.8 inches
to the fourth.
Okay. Now the shear modulus for the pipe is 10,000 divided by 2
times 1 plus 0.2.
0.2, which gives us
4,164.
164?
7, sorry.
7. All right. Now we'll come back over here where we don't know the amount of torque taken by each material yet, so we have the torque of the pipe over J
and G.
Pipe, 7.8 times
4,164, and that is equal to the torque of the rod.
Okay.
Divided by
0.1 times the
3,043.
Great. So that gives us the torque of the rod is equal to 0.01 torque of the pipe. Now, the total torque is 300, so I'll add over here. The torque of the rod is...
The torque of the rod is 3.
3.
And the torque of the pipe is 297.
297. Perfect. Okay. Now
what do? We have to find the stress?
Yeah, we'll find the shear
stress
for each material.
All right.
So the shear stress of the pipe equals the torque of the pipe, which is
the torque of the pipe is 297
divided by times
1.5.
1.5.
It's the radius.
Okay, divided by
7.8.
7.8, which gives us a grand total
of 57 psi.
57 psi. Perfect. We'll put it over here. And we'll do it again for the rod. So 3 times the
times 0.5
radius of the rod
divided by 0.1.
0.1.
And that is equal to 15 psi.
15 psi. Okay.
Great.
We're almost done. We just have to find the angle of twist. And since it's the same for the pipe and the rod. We just have to choose the parameters for one or the other. And again, we want it right in the middle.
All right.
So
now we take the same torque, right? The 3.
We'll do it for the rod.
Mm-hmm.
So 3
times the 30.
Times 30 inches, since we're in the middle, divided by
0.1.
the J of the rod, 0.1, times
the 3043.
43. And that gives us
0.3 rad.
0.3 radians is the rod equal to the pipe.
That was it?
That is it. How did I do?
You did very good. I think if the professor was here, he would give you a star.